Hello everyone, welcome to the Math Canvas. In the last class, I have explained about introduction to the trigonometry, and in today's class, we'll do few sums, few problems. If you have not seen the last class, I suggest you to see the last class because without that, it's very hard. It's a bit hard to solve the trigonometry problems. Here I have something for you. You can just take a screenshot of it. With these formulas, you can solve any problems. This is what I have explained in the last class. So if you know this problem, then that's fine. If you don't know, please have a look. Now let's move to the first sum. I'll start with the basic question. So here you go. This is the question I have. So the question is, in a right angle triangle ABC, 8 centimeters, 15 centimeters, 17 centimeters are the lengths of AB, BC and CA respectively. Then find sin A, cos A and tan A. So they have clearly mentioned that it is a right angle triangle. So let's draw the right angle triangle. They said ABC, but I'm not mentioning the vertex since I don't know which one is the hypotenuse. So here if you see 17 centimeter is the longest side, that is CA. So write down CA. So whichever is left, that is right angle, that is at right angle, which is 90 degrees. Okay, now CA is 17 centimeters, AB is 8 centimeters and BC is 15 centimeters. Let's continue with the question. Then find sin A, cos A and tan A. They mentioned that angle A. So with respect to A, which one is the opposite side? That is BC. And which one is the adjacent side? That is AB. And however, the longest side is always hypotenuse. Now sin A is equals to cos A is equals to tan A is equals to. I already told you with the help of these formulas we can solve any sum. And here what is sine? Opposite by hypotenuse, and cos adjacent by hypotenuse, and tan opposite by adjacent. If it is very hard to remember, just remember one statement, that is old Henry and is old aunt. So O by H is sine, A by H is cos, O by A is tan. That is opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent. Alright, let's continue with the sum now. So what is sine here? Opposite by hypotenuse, cos adjacent by hypotenuse, and tan opposite by adjacent. Okay, so with respect to A, what is opposite side? That is BC, right? BC, and hypotenuse is always the longest side, that is AC. So which is equals to 15 by 17 centimeters. I mean 15 centimeters by 17 centimeters. So however, we don't write centimeters here as it is a fraction. Centimeters will get cancelled. Now cos A is equals to adjacent by hypotenuse. What is adjacent side of angle A? That is AB, and hypotenuse is AC, which is 8 by 17. Similarly for tan, opposite side is BC, adjacent side is AB, that is 15 by 8. Understand? So let's move to the next sum. Okay, let's see the next sum. They said that if 3 tan A equals to 4, then find sin A and cos A. Alright, so what they have given, they given that, let's do the solution. Given that 3 tan A equals to 4, can I write tan A is equals to 4 by 3? Here 3 is in numerator. When I send it to the opposite side, it will come to denominator, right? Okay, so from here, what is tan A? Tan A is opposite by adjacent, right? Tan A is opposite by adjacent, which is 4 by 3. So now let's draw the right angle triangle. This you need to draw the right angle triangle for this type of sums. Okay, so here you need to remember one thing. I have taken a on other two vertex other than at right angle place. So this is opposite and this is adjacent, and here this is hypotenuse. For tan, what they said, tan is equals to 4 by 3, as they have some common ratio, so I'm not taking any common ratio. Without taking common ratio also you can do it. So here opposite is 4 and adjacent side is 3, and we need to find hypotenuse. But how to find hypotenuse? So we can use the Pythagoras theorem. What is Pythagoras theorem? Longest side square is equals to sum of square of other two sides, right? So that is AC square is equals to AB square plus BC square. Here AC is so we don't know AC, we need to find AC. AC square is equals to AB is 3, so 3 square, BC is 4 square. AC square is equals to, what is 3 square? That is 9, and 4 square is 16. 9 plus 16 is equals to 25. Now when I send square opposite side, it will become square root. So square root of 25 is nothing but 5. So what is hypotenuse here? 5. Why I found hypotenuse? Because in order to find sin A and cos A, we need to have hypotenuse, because sin A is opposite by hypotenuse and cos is adjacent by hypotenuse. So sin A is equals to opposite by hypotenuse, which is, so what is the opposite side of A? That is BC, and hypotenuse is always the longest side, that is AC. So answer is 4 by 5. Similarly, cos A is equals to adjacent by hypotenuse, which is AB by AC. Here AB is 3 and AC is 5. Hope you understand this question. Let's do the another sum, but before doing that sum, try to do the sum which is same like this. Let me give you the question. Okay, this is the same type of question like previous one. Try to solve this question. If you don't get, no worries, you can post me in the comments so that I can do it in the next video. Let's go to the next sum. Here is the next question. So given that cot theta is equals to 7 by 8, and then we need to find 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta, and the second question 1 plus sin theta by cos theta. Alright, so however they have given cot theta which is 7 by 8. You know what is cot theta? It is adjacent by opposite. Alright, let's do the sum here. Given cot theta is equals to 7 by 8. Okay, so if you see here, cot theta is equals to adjacent by opposite. Cot theta is equals to adjacent by opposite. Just write down adjacent by opposite here, 7 by 8, and draw the right angle triangle, place angle theta. So with respect to angle theta, this is the adjacent side, and name it as some ABC. BC is the adjacent side and AB is the opposite side. So what is BC? That is adjacent side, that is 7, and AB, which is opposite side, that is 8. So with the help of these values you need to find hypotenuse AC. So using Pythagoras theorem, AB square plus BC square is equals to AC square, right? Let's do that. Let's do it in the next page. So by Pythagoras theorem, AC square is equals to AB square plus BC square. We need to find AC square, that is AC square is equals to, here what is AB? Here AB is 8 and BC is 7, just remember that. AB is 8 square and BC is 7, which is 7 square. 8 square is 64 and 7 square is 49. So AC square is equals to 64 plus 49, so 9 plus 4 is 3, 6 plus 1 7, 7 plus 4 is 11, so where AC is equals to root 113. Okay, where AC is equals to root 113. Just write down the value over here, that is root 113. Now we need to find this. To find this, first of all we need to find the value of sine theta and then the value of cos theta. Okay, so let's find the value of sine theta here. Sine theta is equals to opposite by hypotenuse. So here what is opposite side? Here the opposite side is 8 and hypotenuse is root 113, so which is 8 by root 113. Similarly, cos theta is equals to adjacent by hypotenuse. From the diagram, adjacent is 7 and hypotenuse is 113. Okay, let's do the sum now. What is the question actually? The question is 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. All right, let's do it in the new page. So what is that? 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta. Before substituting the values of sine theta and cos theta, let's see here, is this in the form of a plus b into a minus b, right? It is in the form of a plus b into a minus b, right, which is a square minus b square. So can we write can we use this formula over here? So we get 1 square minus sine square theta by 1 square minus cos square theta. Since a plus b into a minus b is equals to a square minus b square. Alright, so let's substitute the value of sine and cos over here. What is sine value? We got 8 by root 13 and cos is 7 by root 13, right? 8 by root 13 whole square by 1 minus 7 by root 13 whole square. Okay, so that what we get here, 1 minus 8 square is 64 by, and root 113 whole square is 113 by 1 minus 7 square is 49. Same here, root 113 whole square is 113. Now do the LCM in denominator, in the numerator and denominator. In the numerator the LCM is 113. As the denominator is 113, then you need to multiply and divide with the 113 over here, so that you will get 113 minus 64. In the same way, in your denominator 113, here also you need to multiply and divide with 113, so that you will get 113 minus 49. So 113 minus 64 is 49 by 113 by 113 minus 49 is 64 by 113 Here 113 will get cancelled. Therefore the answer is 49 by 64. Okay, now let's do the next sum. 1 plus sine theta by cos theta. 1 plus sine theta by cos theta. We got sine theta value as 8 by root 113 and cos theta value as 7 by root 113, right? So just do the LCM here, that is 113 and multiply and divide with 113 over here, so that you will get 113 plus 8 by 7 by 113. 113 will get cancelled, therefore you will get the final answer as root 113 plus 8 by 7. Got it? Okay, same problem we can also do it in some more easy way. Let's do that. Here we have used right angle triangle and we use such calculations here, but without using that we can do it in a normal way by using identities. Okay, if you see here, these are identities, that is sin square theta plus cos square theta is equals to 1, secant square theta minus tan square theta equals to 1, cosec square theta minus cot square theta is equals to 1. As the question is in the form of sine and cos, so I'm using the first identity, that is sin square theta plus cos square theta is equals to 1. Okay, let me note down the question once, that is 1 plus sin theta. Okay, 1 plus sin theta into 1 minus sin theta, 1 plus sin theta into 1 minus sin theta by 1 plus cos theta into 1 minus cos theta. Here in the numerator and denominator we can use a plus b into a minus b whole square, right, like I discussed earlier. So that is 1 minus sin square theta by 1 minus cos square theta. So since we have an identity, that is cos square theta plus sin square theta, or sin square theta plus cos square theta is equals to 1, right? Can I use that identity over here in place of 1? Can I replace 1 with sin square theta plus cos square theta? Yes, I can. That is cos square theta plus sin square theta minus sin square theta. You don't get confusion. In place of 1, I'm just using the identity, the first identity, and minus sin square theta I'm writing as it is. The same way, in place of 1 here, cos square theta plus sin square theta and minus cos square theta I'm writing as it is. Here in the numerator and denominator, in the numerator sin square theta will get cancelled, and in the denominator cos square theta will get cancelled. So what is left? Cos square theta by sin square theta. Can I write as cos square theta by sin theta whole square? So but what is cos by sin? That is cot, right? So cot square theta. So in the question they have given cot theta is equals to 7 by 8. So you can simply write cot square theta as 7 square. You can simply write it as 7 square or 7 by 8 whole square, which is 49 by 64. This is what we got earlier. 49 by 64. Okay, let's see some sums which is related to trigonometry table. If you see, they asked to find sin 30 plus tan 45 minus cos 60 minus cosec 60 by cot 45 plus cos 60 minus secant 30. I told you that if you know these formulas, then you can solve any sums. So as the question requires this table, so you need to know this table. So in order to know this table, you just know, if you know the sign, then it's easy to find the other, which I have already told in the introduction video. Okay, let's see the sum here. What they have asked, they asked sine 30. What is sine 30? From here, sine 30 is 1 by 2, so substitute 1 by 2, 1 by 2 plus tan 45, from the table it is 1, and cosec 60, which is 2 by root 3, cot 45 is 1, cos 60 is 1 by 2, and secant 30, which is 2 by root 3. If you, so here no need to waste the time. If you see in the numerator and denominator, there are three terms, 1 by 2, 1, and 2 by 3, and the signs are also same, so you can simply cancel this, which is equals to 1. Similarly, we can also find this sum using the ratios table. Tan 45 is 1, so as they said tan square, so it is 1 square. Tan square 45, so it is 1 square. And cos 30, which is root 3 by 2. Cos 30 is root 3 by 2. Cos 30 is root 3 by 2. So substitute the value over here. Root 3 by 2 whole square minus sine 60 is also root 3 by 2 whole square. Here don't waste time by using calculations, as here we have plus and minus with the same number, so you can cancel. Here 1 square is 1, 1 into 2 is 2, so answer is 2. Try to keep it in simple and short. Okay, and here we have some different type of sums. If you see the first question, if you see the question, tan, we need to find the value of tan 36 by cot 54. Come on, we don't have, like, we don't know the value of tan 36 or cot 54. Like this, like I didn't mention angle 34 and angle 36 and 54 here. I only mentioned the standard angles, but how to find the value of tan 36 and cot 54? No need to worry, here we have some properties. That is, if you see here, tan 90 minus theta equals to cot theta, or cot 90 minus theta is equals to tan theta, right? Using this formula you can solve those forms easily. So change any one. See here, with respect to tan, we have cot, and with respect to cot we have tan, vice versa. And similarly for sine it is cos, cos it is sine, and secant it is cosec, cosec it is secant. So as we have tan and cot, change any one. If you want to change cot, tan into cot, you change it, or cot into tan, it's up to you. I'm changing tan into cot, so tan 36 can be written as 90 minus 54 by cot 54. So as I mentioned there, tan 90 minus theta is cot theta. Tan 90 minus theta is cot theta. So in place of theta we have 54, therefore tan 90 minus 54 is cot 54 by cot 54. Cot 54, cot 54 will get cancelled, so the answer is 1. Similarly, we can now solve this one. So here cos, with respect to cos we have sine, and with respect to sine we have cos. So use convert any one, whether sine to cos or cos to sine. And converting cos to sine, so cos 12 can be written as 90 minus 78, right? Where cos 90 minus theta is sine theta. In place of theta we have 78, therefore cos 90 minus 78 is sine 78 minus sine 78, sine 78 minus sine 78, which is 0. Hope you all understood. So here same cosec 31 secant 59. Here cosec and secant, with respect to cosec we have secant, so cosec can be converted into secant using the complementary angles. So if you see 31 plus 59, which is 90, 31 plus 59 are both a complementary angles, so cosec 31 can be written as cosec 90 minus 59, so which is secant 59. Answer will get 0. You try doing this three sums, I strongly believe that you get this answer. Okay, yeah, they said that show that tan 48 degrees into tan 16 degrees into tan 42 degrees into tan 74 degrees equals to 1, right? Same, using those complementary angle property we can solve this. All right, so first of all you need they have given four angles here, I mean four angles. You need to find for its complementary angle. What is the complementary angle for 48? That is 42, right? Like 48 plus 42 is 90, right? In the same way complementary angle for 16 is 74, like 16 plus 74 is 90. So change any one, like if you want to change 48 then don't change for 42, if you want to convert 16 then don't convert 74. Okay, so tan 48 can be written as tan, I'm doing directly LHS. Okay, tan 48 can be written as tan 90 minus 42. I'm writing tan 42 here. Okay, I have written this 2, and then tan 16 can be written as tan 90 minus 74 into tan 74. Here tan 90 minus theta is cot theta, which is cot 42, and into tan 42, and tan 90 minus 74 is cot 74 into tan 74. If you see both the angles are equal, right? Now we know that tan and cot are reciprocal to each other, so tan theta into cot theta is, yes, it is 1. Tan theta into cot theta is equals to 1. So you should make sure that both the angles should be same. Here both the angles are same, so tan theta into cot theta is 1 into, again tan theta into cot theta is 1, so which is equals to 1, that is RHS. Therefore LHS is equals to RHS, hence prove. Got it? Okay, let's see the next question. Express sine 81 degrees plus tan 75 degrees angles between 0 degrees and 45 degrees. Okay, yeah, what they asked is, they gave they gave the trigonometry ratios with the angle which is more than 45 degrees. We need to convert between 0 and 45 degrees. Simple, just using the previous method, just do that. Sine can be written as sine 81 can be written as 90 minus 9 plus tan 75 can be written as 90 minus 15, right? 90 minus 9 is 81, 90 minus 15 is 75. So as we know that sine 90 minus theta is cos theta, so it is cos 9 plus tan 90 minus 15 is cot 15, right? Now if you see the angles are between 0 and 45, right? Okay, let's see the last sum. Here the question is, express tan theta in terms of sine theta. It means you need to get the tan value in terms of in terms of sine theta. Here we know that tan theta is equals to sine theta by cos theta, right? But here we have cos theta, but still we need to get only in sine theta. So for that what we have to do is we need to convert cos in terms of sine. So how to convert cos in terms of sine? Can I write cos theta as 1 minus sine square theta under root 1 minus sine square theta? Therefore here we got tan theta in terms of sine theta, that is sine theta by 1 minus sine theta by under root 1 minus sine square theta. But how we got cos theta as under root 1 minus sine square theta? Here is how. Using identity, sine square theta plus cos square theta is equals to 1, right? So can I write cos square theta is equals to 1 minus sine square theta, and then sending square root to the opposite side become sending square to the opposite side will become under root, that is under root 1 minus sine square theta. Here is how we got cos theta is equals to under root 1 minus sine square theta. Okay, all right, this is all about this section. In next class I'll explain prove that sums, which is very important in the exam. You might get definitely, like there are 90% of chances you will get the prove that questions. So I'll explain that in the next class. Have a good day.